Well, good afternoon and welcome to our Avlite webinar number 1, where today we're going to introduce and focus on Heliport lighting and solutions capabilities. For those that aren't familiar, my name is Michael Walker and I look after our global sales, marketing and digital for the Avlite company, and it's my pleasure today to introduce my two colleagues. Firstly is Mr. Wade Evans. Wade is our global product and solution manager for Avlite and our digital portfolios. And I'd also like to extend a warm welcome to Vicky Clarke. Vicky is our Australia and Pacific sales engineer focused exclusively on Avlite. We've got a fantastic program today. We should only take about 45 minutes in total, and the first 35 minutes will focus exclusively on our presentation. In terms of ways of working, there's a facility at the top of the application where you can log your questions. You can log those questions throughout, and at the back end of the session, we'll then work our way through providing answers to those questions. In terms of today's agenda, we're just going to have a brief introduction in terms of Avlite and the market trends. Then we're really going to deep dive into the applications and the solutions and the needs that you and your customers, partners, etc., may need to be able to generate a solution and ultimately a successful installation. And then we'll talk through the range of products and solutions. And in the second half of the presentation, Vicky's going to present a case study on the Hobart Hospital. As I said there, the questions and answers will be answered at the back end. So without further ado, we'll get stuck in. And again, a big thank you to all of you, wherever you might be, who's dialing in today. So a little bit about Avlite Systems. Avlite is part of the Sealite group of companies. Sealite was founded in 1982, but the Avlite Systems business was founded in 2004. So this is what our 17th year of developing specialised solutions across the three verticals, if you will, of the aviation industry. So we focus on airfield lighting solutions, obstruction lighting solutions, and obviously the heliport lighting solutions. So they're the three key verticals. And then within that, there's applications across both civil and military. And the focus for our business is really about providing those turnkey solutions, whether it be civil, government, defence, humanitarian aid applications, etc., etc. That's where we focus our energies. And one of the things that really sets us apart is that commitment to research and development and agile manufacturing, which today makes us one of our industry leaders, which we're proud to be. In terms of Avlite Systems, we're probably today across those three verticals, certainly for solar, we would have the world's most complete line of third-party certified fixtures, and our focus there is always the FAA and the ICAO standards, which are the two big global standards, and then within that we'll focus on regional approvals on a per needs basis. The image you can see at the bottom of that slide there is our global headquarters, which is in Somerville, Victoria, Australia. And for those that might be familiar, we're currently all in stage 4 lockdown as we fight to combat the COVID-19 pandemic. And so all of us today are coming from our work from home environments. And many of the staff, including Vicky, have been, and Mason, have been working at home now for some 6 months. So within this facility, it's purpose-built. And we're incredibly proud to focus on our design development through our full stack engineering team. And then once we've then completed that design and development, it then works its way through the various aspects of manufacturing. So again, we're a little bit different to some of our peers within the industry, where we focus an enormous amount of investment in our own in-house manufacturing capability. So we'll build dies and tools in terms of injection molding. We'll run those injection molding machines in our own plant and equipment. We run a full SMT line, surface mount technology and electronics, right the way through our assembly. And the final point there, which I'll touch on in a moment, in terms of COVID-19, we've been incredibly proud this year to have not lost a single hour of productivity lost due to COVID. We have a saying internally that our health is our wealth, and it's been incredibly important that we've taken really strong measures to implement and support our staff and our well-being, and ultimately you, our customers and our partners out in industry who rely on these solutions and technology to fulfill your operational needs. Just before I hand over to Wade, just wanted to sort of touch on the industry. It's an incredibly exciting industry, and we've continued to see the growth in both craft and their usage and application grow steadily, and certainly in the last sort of 10 to 12 years that I've been focused on the aviation side of our industry, our business. So some of those trends, we've seen a stronger need around that operational space and managing the operational envelope around the use of helicopters. If we think about those urban areas that are increasingly growing and becoming more congested, that need to be able to identify and manage the heliport operational space has become really, really important. And that's also not just in those high growth urban areas, but also out to the regions. Secondly, it goes without saying that COVID has placed a significant demand on the health industry, not just in Australia, but in all of your countries, right the way around the world. And so that need for being able to provide safe landing, safe guidance in terms of guide slope and approach to get those patients and get the people that need that critical care into that medevac space has been really, really significant. The next couple of trends that we've seen is a strong movement towards control and monitoring. So it's important in terms of some of these systems that they're always on. They provide a critical need in terms of industry, but that need to be able to monitor the health or the status of the network, and then secondly, to be able to control it. And Wade's going to drill into that a little bit further in terms of the application and the need from industry. The fourth is, certainly in my time, and Wade and Vicky will attest to that, we've seen a strong sort of shift from what was once an elevated prevalent industry towards inset. And as we've seen, some of the specifications around the surfaced area of the helideck or the helipad or the heli landing site, managing issues like dynamic rollover, etc. There's been that stronger need and identification for inset lighting to remove any and all hazards. The fourth or the fifth issue there is system level redundancies becoming critical. So it's not just a case of being able to have a single controller. Many customers, in terms of their operational profile, might require a second controller, and certainly the need to be able to manage distributed power systems becomes really critical, and none more so than within that medevac and that medical application. And then finally, this is something called out from our consultants and some of the systems integrators and contractors, of which some of those that have joined today's call, that need for a turnkey system. And so as we've developed our portfolio of solutions, it becomes critically important that we can support our customers and our partners and those integrators with a full turnkey solution. So that's just a little bit of a high level view in terms of where we've seen the industry and where it's headed. What I'd now like to do is hand over to Wade Evans, and Wade will now walk us through a deeper analysis of the portfolio. Over to you, Wade.
Thanks, Mike. Hi, everybody. So like Mike said, we'll do a bit of a deep dive here into just how to come about your helipad solution or heliport solution and just sort of work through the technical components of it, and then obviously look at the Avlite product and how we sort of meet those application requirements and that sort of design requirements that come out of that process. So when it comes to picking and selecting your heliport solution, there's a lot to think about. Ultimately, it fills a funnel methodology where you start with quite a large number of options and implementation possibilities, and then you really funnel it down to a very specific installation or very specific implementation based on all the criteria as you work through the funnel. So at the top of the funnel, what we really start talking about is regional regulations or regional requirements. That's where there's specific standards applied to the heliport or the helipad installation. You're talking ICAO or FAA as guidelines, for example, but there's also localized regional specifications as well. You know, Australia has its own specific requirements. EU countries have theirs as well. So globally, there's a lot of different regional specifications. So it's important to know what regional specification we're working to so that we can really filter down the needs and the requirements to really be a specific solution and a specific implementation. So once you've determined the regional regulations, you then move into the application. There's 4 key application spaces that we deal with at Avlite. Now they are surface level helipads, elevated heliports, helidecks, and temporary helipads. Obviously surface level heliports, we're talking about terrestrial systems, systems that are on the ground. When we talk about heliports, we're talking about obviously helipads that are elevated on a building or some other primary structure. And then helidecks. Helidecks are ultimately a type of elevated heliport, but they're very specific in terms of their application and their implementation, and they're really quite catered towards oil and gas applications. And then finally, temporary helipads, where we're talking about rapid deployment, emergency service type applications, where you need to set up a temporary helipad and it's the best possible solution given the situation, rather than a specific design criteria for the temporary helipad. So we'll work through those in a bit of detail once we work through the Heliport solution process. So once you've been able to work out what is your regulation, what is your application, we really start talking implementation. And this is where we get involved with the consultant network and also the contractor, as well as the end user themselves, to really decide what the appropriate implementation is. So when it comes to the implementation, you may have a helipad like the one on the right there, and that can be implemented in quite a few different ways. So the regulations, whether they're FAA or ICAO, will give guidelines on minimum criteria, but then that can then be leveraged to either increase usability. There might be specific site obstructions, for example, that mean that the layout and the lighting requirement needs to be catered to that. So when it comes to the implementation, is there a FATO? Is there a TLOF? Typically, you need both. If it's a terrestrial system, depending on applications, they can be coincidental as well. What are the size of those two areas within the landing zone? And then how are they implemented? Is it green perimeters, for example, for FAA applications, green and white for ICAO? Is an API or an ADI, which is approach path indicator or approach direction indicator, required? That all depends on, once again, the helipad design, defined by typically SMEs or consultants within the helipad industry. And then whether or not how that is implemented specifically. Color is a component of that, but then also location, and then obviously power feeds as well. So then we move on to the IWI or windsock. Is that needed? Yes, no. Obviously, once again, all very specific to the installation. And then is flood lighting required as well? Flood lighting is a unique one. There tends to be a bit of a gravitation away from flood lighting in a lot of implementations, especially on elevated systems due to glare and induced glare for the rotary pilots themselves. However, it's all dependent upon, once again, the installation. So once you've defined the implementation components, you then move on to how you implement it in terms of connectivity. How's the heliport system connected to the larger services? And how is it actually going to function and be usable? So what is the input power required for the system? Is it a wired system, or is it a purely solar system for a regional or a remote location? If it is wired system, how is it wired? What kind of power feeds are provided towards the lighting system? Is there a UPS in the loop for redundancy? If so, what kind of feeds are provided in and out of that UPS system? And then finally, and this goes towards the trends that Mike mentioned before, what are the specific control and monitoring requirements for the helipad installation? As we've seen, there's a lot more control and monitoring requirements going into these helipad installations. End users need to know that the system is functional or be able to control it remotely or somewhere else within the building. So it's important that this information is captured up front so that it can be built into the system, and that you can also meet the end user's requirements. So once you've defined that connectivity of the system, we then start looking at how you use it. Is it critical infrastructure? Is it in a permanently manned installation? Is there someone there to always turn it on? Is it purely a manually controlled system? Is it pilot activated, which is relatively autonomous? If it is pilot activated, what requirements are associated with that pilot activation? Typically, PALC systems take precedence over any manual activation, but it all depends on the standards being leveraged. And then are there any environmental factors? That, conditions such as weather, exposure, location, climate, all of those key criteria play into what lighting is picked and then what control system is mapped around it. So that's how to define the heliport solution. And then as we've listed throughout that process, applications form really a core part of that decision process. So when we go through the applications, we start off with terrestrial or surface level heliports. This includes all heliports located on the ground level or on ground structures or on the surface of the water. By that, we mean we're talking about implementations, say pontoon implementations on the surface of water. It can consist of a single or several helipads. If you're talking about an airfield, which also services rotary applications, you'll see that there can be multiple helipads stacked on that airfield, as well as also servicing fixed wing aircraft. Utilised in a wide range of industries, including commercial, military, and private operators. You can see on the right here, the image is just its typical implementation. And terrestrial helipads or surface level helipads typically have additional functionality attached to them in terms of the lighting layout. You have a taxiway in this example specifically based on, say, a helicopter stand and a parking area that requires a taxiway application, as well as a pretty specific approach section here as well, where there's mounted fixed approach lighting for that terrestrial application. After that, we move into the elevated space. Obviously, this is where we see a lot of the trend lately in terms of the move towards what applications are being used more widely. and this is the elevated space. So anything fits within the elevated heliport application is located above ground, and it's typically on a raised structure. It's usually located on top of commercial buildings, residential buildings, or hospitals, with obviously hospitals being the one we see the most of recently. And it's utilised by emergency services, commercial or private operators, and other associated industries. So when it comes to elevated helipads, there's a couple of key criteria that needs to be defined. TLOF and FATO on a lot of elevated applications can be coincidental, which means you don't typically need that two segregations of areas. You don't need the internal TLOF and the external FATO. They can be one in the same. It all depends on size of helipad, application, and then need of use of that elevated helipad as well. So that provides some flexibility in terms of design and implementation, but obviously being an elevated structure, there's a lot of other design criteria that needs to be taken into account as well. Typically we see these implemented with inset fixtures due to the rollover risk, but then flood lighting is also implemented to some degree as well. From elevated, we then move on to helidecks, which are a specific type of elevated heliport. They're located on fixed or floating offshore structures typically, and they're very specific, like I said, to ship and oil platform applications, predominantly used by the oil and gas industry. This isn't a space that Avlite plays in particularly because it implies a lot of certification overhead on the fixtures themselves. It needs to be explosion proof, needs to be very specific for the application, being predominantly leveraged by oil and gas. However, if there's caveats to that, not all of these oil and gas applications require that level of certification, but the majority do. So there are instances where we have played in the space and done solutions for these kinds of applications. And then finally, we look at the temporary application. So this is once again a best effort approach where it's ultimately about setting up a helipad or a landing space that can be used by emergency services to give some sort of indication of landing location, conditions for landing, and approach direction as well. It's really designed around those temporary and rapid deployment applications used in medevac emergency services. And ultimately, it's about being able to be quick, rapid, flexible, while providing some level of guidance and lighting. So we've gone through applications, we've gone through the process, and then what really sets Avlite apart is really our solutions capability. So rather than as being a standard OEM supplier where we just provide the product and then stand back and allow that to be implemented by others, we also offer this solution capability where we're sort of there all the way through. So we can offer turnkey systems, and by that I mean a system that's completely packaged up. That can include control systems, lighting, third-party product that we can also build into our system offering. And it can be bespoke or standard in design. So when I say bespoke or standard, bespoke is usually catered, very specific designs, catered to very specific requirement sets. Or we also have a range of standardized solutions or standardized designs that can be leveraged and implemented in a couple of different ways that allow you to meet end needs while maintaining the efficiencies you get from standardized designs. Our solution capability gives us a few other value adds. We're able to integrate into overarching management systems when we're talking about, say, BMS or SCADA or any of those other third-party high-level management systems that allow for that remote monitoring and control capability. We work heavily with the consultant network, operators, end users, contractors, and integrators. That's our day-to-day work when it comes to our solution capability and our solution function. So we're quite skilled and versatile in that respect. Having this capability, this solution functionality, allows us to really deliver the best possible outcome for customers where predefined product doesn't fit. So in a lot of these, you've seen from everything we've gone through, there's quite a broad scope to the possibilities for helipad applications or heliport applications. And being able to provide these bespoke systems really allows us to cater our design into that sort of customer-specific needs, which really offers the best possible outcome for the customer and everyone in the customer channel, from contractors to consultants, all the way through to the end user. We're able to provide technical guidance both pre and post sale. We're here from start to finish, but we're able to provide that technical input where we can provide OEM, SME, subject matter expert input through the consultancy process, for example, as well as through the OEM build as well. In terms of what sets Avlite apart from all those other OEM suppliers, so the solution capability really forms the background and backbone of what sets us apart, but we fit in a lot of respects. So we fulfill many roles and provide a lot of value add across the entire life cycle of a helipad design and helipad implementation. We really are that cradle to the grave supplier, which is really supported by that solution functionality. We're able to offer that pre-sales engineering consultation input as well, which means we can provide appropriate regional and requirement guidelines. Now we can say, how do you leverage ICAO? How do you leverage FAA to meet your needs? If you've got specific requirements or regional requirements, we can really work with customers and work with contractors to come up with the best way of implementing those requirements and those regional certifications and specifications to really give the best possible outcome. We can provide consultation and engineering input in terms of the helipad lighting layout and provide that guidance around design. It's always important to engage, potential OEM suppliers at the design level. And the reason for that is that you ultimately can't come up with a design that no OEM can supply. So we can engage at that level to really make sure that the process is as clean and smooth as possible, so that what is actually produced at the end is not only commercially viable, but is also technically viable as well. The solution design itself, so once we've moved past, say, the consultant component, we can then also do the detailed electrical design and system design and fixture design for both standardized and bespoke turnkey lighting control systems against the helipad requirements. This is where we really do a lot of our work, building those bespoke systems to meet those customer needs. And obviously, finally, we're also an OEM supplier, which means we can manufacture and supply those complete systems. So once again, cradle to the grave, kind of capture all the components of it to really offer that value add. So that's what Avlite offers. And now when we look at product, we'll see how we can marry up that product to those application spaces and to those customer needs. So first and foremost, we start talking about temporary applications. So we're talking about our HL EMS kit here, which is our temporary portable lighting kit. It's an IP67 system, and that includes everything from the fixtures through to the enclosure that they're housed in. Can provide up to a 4-kilometre range, long life, user replaceable batteries. Small and large kits are available. And obviously, being a temporary application-based product, it's really about portability. So it all comes in a portable enclosure, as you can see there on the right, to allow for rapid deployment and transportation and storage as well. So that's our primary temporary application or temporary product to suit the temporary application. And then we move through into our solar fixtures. So solar has really played a part in the remote and regional application spaces where standard AC feeds aren't available. So in implementations where you don't have access to that AC feed, you don't have access to typical services, solar really comes into its own. So we have a range of solar products. At the top there, we're talking about the radio-controlled solar perimeter light. It has over 40 hours of continuous operation, three-step intensity adjustment via the RF controller, and that really allows you to be able to control and independently modify the intensity of that fixture. Once again, it comes into its own in those regional and remote locations. That's then complemented by the floodlight fixture, which is our solar floodlight application. It's radio controlled again. Obviously, all of our solar systems typically are RF controlled because they don't have access to a wired control system. So the solar perimeter light, or solar floodlight, has over 40 hours continuous operation as well. And then once again, it also aligns with the 3-step intensity adjustment via the RF handheld controller. At the bottom there, we're talking about the AV70, which is our solar aviation and taxiway light. That's designed specifically for those taxiway applications. It's IP68. It has dual high-performance solar modules, which really makes it sustainable anywhere in the globe. And then once again, also has RF control. So that's our solar product line. And now we'll move on to our wired product line. So when it comes to wired, ultimately what's leading the way these days, especially with market trends, is our inset helipad line. It's a near flush mount system with only about 3mm protrusion. So it's technically a semi-flush fixture. And that's required in order to meet a lot of the standards. So you can't have a fully flush fixture and still be able to meet the ICAO needs, hence why it's a near flush mount. It can provide visual and/or IR concurrently. That means that you can provide, obviously, NVG guidance for those using NVG goggles, while also maintaining visual indication as well, all in a single fixture without needing to select whether or not it's visual or IR. It all comes together in one. Variable intensity adjustment has a 0 to 10 volt feed on it, which allows us to control it with quite high resolution and really cater the intensity of that fixture to the desired needs of the implementation and the solution itself. It's really easily integrated into control systems, having those direct wired connections, and it's really what's leading the way in terms of our movement and trends within the industry. That's then complemented for elevated fixture applications, which with our HL, AC or DC fixture. It's visual or infrared, not both. and then it's got simple on-off control. So this is really designed around hard-mounted applications where inset fixtures just aren't viable, where the coring, where the actual civil works aren't suitable. Then you can move on to an elevated fixture. Obviously, it doesn't have as many features or functions when it comes to control and monitoring because it's simple on-off control, but it certainly meets that need when you need to bolt the fixture onto a deck in order to meet that elevated requirement without having to do the penetrations into the helipad itself. Both of these fixtures are then complemented by the floodlight itself. It's an adjustable floodlight. It comes in DC or AC variants. It's got that optic hood, which reduces the glare. Now that's really critical because, as I said before, floodlights can be a little bit contentious in the industry around the amount of glare they produce and whether or not they hinder or help navigation. So it's really important that it can be adjusted and catered towards the application needs, as well as to meet the rotary pilot's desires as well and preferences. It's got variable intensity adjustment. Once again, it's got fine resolution. It can be all the way up. It's a 0 to 10 volt line and can be adjusted all the way up from 0 to 100%. And once again, can be catered towards specific implementations and control systems. And it's really quite easily integrated using a similar mechanism to what the inset light does as well. This is then complemented by another new product to the market, which is our Happy system, LED Happy. It's ICAO compliant. Comes in AC or DC variants. Visual and IR are available within the same optic, which when you start thinking through the optical design is quite a tricky challenge. And then you've got RF, heated lens or tilt switch options available. This is really leading the way in terms of Happy applications in the industry. It's a very specific, very compact product that really meets the needs of that Happy application. Rounding it all out is our control and monitoring solutions. As you've seen, as I've gone through the different product, everything is kind of integrated into these overarching control and monitoring systems. And that means you really need something to tie it all together. So we start off with our HL Control T1. This is our standardized Type 1 helipad controller. It can serve up to 24 perimeter lights, 4 floodlights, and 1 windsock. Comes in either AC or DC variants in terms of the input. Obviously, we see a lot of AC inputs given the application. It has a manual control, including intensity selection and independent floodlight activation. That's really critical because, once again, some people and some implementations don't particularly like the floodlight activation, so we've made it independent, and that allows it to be enabled on preference. It also can be complemented by optional RF control or PALC add-on modules. The RF control can be both input and output, so the system itself can actually receive a control from a handheld controller to activate the rest of the system, or the primary controller can actually activate solar systems or other RF controlled devices as well. Obviously, PALC is a key criteria for most helipad applications, so it services that add-on modularity and that add-on functionality as well. This is supported by the ALS-RR, a radio controller for RF lights. This is the handheld controller that you may be familiar with. It's a worldwide accepted radio control on common frequencies globally. It's 128-bit security encryption, ability to switch between visible and IR through the controller itself, and then independent light group control is also supported. Supports up to 16 light groups, so based on how you configure the network, you can actually set up different light grouping to enable different components of the helipad to turn on at different times. And then finally, we're talking about the PALC system, or the AV PALC, which is our pilot activated lighting control system. It's easily integrated into the controllers themselves or other systems or any existing systems, as well as wireless networks. Comes in AC or DC, and there's a couple of options available depending on the certification requirements. For example, CASA has a specific requirement for it compared to, say, ICAO or FAA implementations, depending on the region or the location. I'll now hand over to Vicky just to run you through one of our flagship case studies and go through that in more detail.
Awesome, thanks Wade.
You're on mute, Vic.
Apologies for that, everybody. The mute button went missing off my screen and I couldn't figure out how to unmute myself. Good afternoon, and thank you for attending. I'm just going to do a quick run through of the case study for the Royal Hobart Hospital, give you a little bit of an overview as to an actual installation that we have prepared and supplied. So the Royal Hobart Hospital is Tasmania's largest hospital, that'd be Tasmania in Victoria. It's the second oldest hospital in Australia, and services over 250,000 people across the south of the state. Due to it being a major trauma centre and a general hospital upgrade meant that the old helipad became obsolete and inappropriate. And so the hospital decided to design a new helipad, new helideck, elevated at the top of the new hospital, enabled to facilitate larger helicopters, more frequent and more consistent arrivals. A customised solution was required, with concentrations around optimal performance of the lighting, minimum maintenance and ease of installation. A PALC was deemed essential, the pilot activated lighting controller, to give pilots on approach to the hospital the control of the lights. In addition, the lighting also had to follow international and domestic guidelines for medical helicopter operations, both in terms of the individual fixtures and the overall layout of the lighting system. In partnership with Aluminium Offshore, who are the Helideck provider for the Royal Hobart Hospital project, Avlite came up with a helipad solution. We were chosen because we had the customised specialised controller, which directly integrated into the pilot activated lighting controller, allowing for the pilot activated lighting as a primary operational mode with secondary local manual control. So this single control box provided power and performance control for 35 elevated heliport lights, 10 inset lights and 8 floodlights, outlining the edge of the helipad, the approach direction indicators and the floodlights respectively. This helideck lighting solution helps to provide the Royal Hobart Hospital with the absolute best possible performance to be able to bring in these larger helicopters with more consistency, more frequency, and across a broader range of weather conditions than they've ever been able to achieve before. This helideck is the only place at the hospital that helicopters can be brought into land, and as such it is vital, absolutely critical, that it is consistent and always operational. So that's just a very top level overview of the system. Obviously, we're more than welcome to take questions. And at this point, I'd like to hand back over to Michael to answer some questions. Thanks, Michael.
Wonderful, Vicky, and thank you to Wade and Vicky. So we'll now pivot through, and if we've received any questions, we'll work our way through those now. Alrighty, looks quite comprehensive in terms of today's engagement. So I guess if there's no questions from the audience, I would just like to extend a very warm thank you. Okay, we've just got a small chat. So this is a question, I'll ask this of you, Wade. Heliport beacon, is that something that Avlite's able to source and or integrate and supply?
Yeah, so we're able to integrate and supply. We don't produce one ourselves. There's for a couple of key reasons for that. Predominantly the specifications around helipad beacons or heliport beacons are quite intensive. So you really need to be a specialist supplier in terms of heliport beacons. And you really need some specialised fixtures to do it. Having said that, we do integrate them quite regularly into our systems. It's just not our level of expertise to be building heliport beacons ourselves. So we typically take other suppliers and integrate those into our overarching helipad offering.
Yeah, thank you, Wade. The next question relates to daytime intensity, and the participant has asked, are we able to increase the intensity for daytime use or daytime operation? So just ask you to comment on the intensity steps, Wade.
Yeah, we certainly can. So our standard helipad solutions don't typically have a photocell enabled or a photocell integrated into them, but it's certainly something we do in a lot of our other application spaces, and certainly something we can do on a helipad system. Obviously, that would just be the photocell dictating whether or not it was day or night time, and then we'd have intensity mappings based on that. So it's certainly possible. It's just not a typical implementation, but it's certainly something we can do.
Yeah, thank you, Wade. The next question is, I guess it's a bit of a commercial question. It's quite a broad question. What's the most affordable solution for a heliport? Would we view that solar might be more cost effective versus an inset or an elevated solution?
Yeah, it really comes down to your implementation specifics and obviously the application itself as well. So for those remote and regional applications, you're definitely going to have a more cost-effective solution with solar, because you don't need to be able to run services or run new AC feeds, power feeds, and everything else that you need in order to run a wired system or a traditionally wired system. There's a couple of ways to do solar systems as well. You can do the solar fixtures, but you can also do inset fixtures powered off of a primary solar bank. So you can kind of get the best of both worlds. So if it's not an existing wired system, then solar is definitely, or it's existing powered system, then solar is definitely going to be the more affordable option. But if AC is available, AC power, or an existing DC feed off a UPS, for example, then wired non-solar is definitely going to be more affordable, because obviously the product associated with solar has to have more infrastructure in it in order to sustain that solar recharge.
Yeah, okay, Wade. Thank you. We've got an architecture question around power, and the question is, for earthing and lightning protection for our lights and our systems, is there any measures or solutions that we can provide to ensure the least impact or the least risk to the lighting fixtures and the system itself?
Yeah, there certainly is. So obviously when it comes to lighting surge protection, it becomes a very involved process. Anyone who's worked in lighting or surge protection knows that you've really got to cater it to the system and the application and what you're trying to prevent in terms of your surge and your lighting characteristics. But the way we would typically implement that is we would have our control system powering all of our lights on one side of the interface, and then sitting before that, we would have the appropriate surge protection equipment. So surge protection and lighting protection is all about what you're trying to protect. Typically, when it comes to a lighting application, you're trying to protect flow from the lighting system, which might be exposed to lightning strikes, for example, back down to the primary generation system. Rather than trying to protect the lighting fixtures themselves, you're trying to protect the impact of that down to the much more expensive distribution infrastructure. So we've certainly done that. We've done a lot of those implementations now, where we've catered some type 2, type 3, and even type 1 surge protection into various helipad installations.
Thank you, Wade. I've got a question for Vicky. What's the process that Avlite undertakes to support a customer to quote and specify a customised heli solution?
Thanks, Michael. Great question. So initially what we would do is ask you to reach out to your local sales representative. So the Australia Pacific region would be myself. And we will start off by running through what it is that you are hoping to achieve, what your ideal outcome is. So whether that's in terms of elevated or terrestrial helideck, whether that's meeting certain requirements, whether you've got a budget in mind, how you want to power it. So we start off with, as Wade mentioned earlier, this bigger picture, and then we funnel down through the different options, identify one, maybe two different configurations, and then help you with the design, maybe referring you back to the regulators if there's any specific regulatory questions that need to be clarified.
Yeah, thank you, Vicky. It's a question back on the rotating beacon. Why has Avlite stopped producing the AV155 beacon? introduce you
Yeah,
a bit
so
of Wade.
very specific product question. Ultimately, it's around certification requirements. So in order to be a compliant helipad beacon, it needs to maintain some pretty specific intensity and flash characteristics. And obviously, the trend in the market is towards more regulation and more certification. So we can't really provide that. Not being able to provide that certified fixture means we don't want to really be able to integrate it either and support it going forwards, because it's really ultimately a non-compliant build. So rather than doing that, we source a appropriately certified version of it and integrate it accordingly. A lot of those third-party beacons, they're just a OEM product. They're not integrated necessarily, and they don't always have the appropriate interfaces. So we add the value by taking those third-party products for a helipad beacon specifically and being able to integrate it into a much larger system, turnkey, hassle-free.
Yeah, thank you, Wade. Another question relating to the windsock, and the question is, can Avlite support or supply a Helideck windsock or illuminated wind direction indicator?
Yeah, we certainly can. We have our own version of it. We can also source a very specific third-party equipment as well to meet very specific needs if there's a certain certification level or a certain type of windsock that's required. But we've certainly sold a lot of those on elevated helipads. Now, for helideck applications, once again, when you start talking about X-proofing, if it's a specific oil and gas application, that would be different. But if you're talking more just elevated helipads, then yeah, we've certainly supplied quite a few of those and can source whatever is required to meet the needs.
Thank you, Wade. The next question is a really interesting one. I'll probably start with you, Wade, and then Vicky, if you have any additional commentary. In our experience, have we ever managed to convince a customer to change the helipad project specification from that of a hardwired solution to a solar solution, and the participants asking from an ease of installation or maintenance perspective? Start with you, Wade.
Yeah, I would say we have, but it all really comes down to that funnel methodology. So ultimately trying to give the best outcome for the customer. If a wired system is the best outcome for them, obviously we can supply the equipment, but ultimately we want to make sure that they get the best possible outcome. So, if wired is the best for their application, and it gives them the most reliability, it gives them the highest application and output, then that's what we'd want to push them towards, or help them facilitate them get to that answer. But there's a lot of instances where solar would have an advantage, and that's where we bring that into the conversation. So rather than pushing them in one direction or the other, we're really there just to be consultative, to work out what is best for the application, that specific implementation. There's a lot of constraints and there's a lot of variables when it comes to helipad installations. What's available, what isn't available, what is going to be produced the best through life support, what suits them in the long run, rather than just the short term. So we take that all into account with our recommendations.
Yeah, thank you, Wade. The next question, probably start with you, Wade, but possibly Vicky. It's a really good one. It's got an strong Australian flavour to it. And the question is, will the Avlite illuminated wind direction indicator become MOS 139 compliant, be that a solar or a hardwired option?
Yeah, it's a good question. The thing that sets MOS 139 standard away from any of the typical wind direction indicator is around illuminance of the external illumination of the windsock itself. And there's a higher requirement in the CASA spec. So we've looked at it a few times. It's something we've got on our roadmap to look at and see how close we can get to that compliant fixture. It's not something that we currently have in development, but it's certainly something we'll be looking at as we move forwards and see more movement in the helipad space especially.
Yeah, thank you, Wade. The next question is related to case studies. So does Avlite have any project references in the Middle East for heliport projects, be that civil or military? We certainly do. That person is currently listed as anonymous, so if they'd like to get in contact with us, you can contact myself at m.walker@avlite.com, or accordingly one of our colleagues, Wade or Vicky, would be delighted to follow up with that supporting information. But we certainly have done a number of those applications for both civil and military. We've provided solar, standalone, exclusively solar solutions. We've also provided a series of inset and elevated solutions. And the final question relates to the compatibility. So the questioner here has asked, what's the compatibility to install an Avlite inset light on an existing inset or base can from a pre-existing manufacturer? So just a comment there, if you will, Wade.
Yeah, look, it becomes a component of technical risk. Ultimately, what is certified or what is designed and tested as compliant on our product is our standard base cans with our standard fixtures. And that means that it's sealed, that it has all the appropriate environmental certifications or environmental testing associated with it, so that we can reliably say this will work in the application. Now, taking our fixture and supplementing it onto another base can leads to some technical risk. It's not something we would typically entertain because ultimately, especially for the end user and the customer, it'd be more cost effective to replace the base can itself. Because once you start looking at customized adapters and everything else, it starts to increase the cost once you start looking at the overheads of engineering, testing, everything else. So it starts to become less value add or less of a viable commercial proposition. So we typically recommend that you stick with the standard inset basis.
Yeah, thank you, Wade. And just following on from the base can question, does Avlite supply, I guess, what sizes in terms of base can does Avlite supply? And do we supply a deep base can by definition?
Yeah, so we have a 5-inch and an 8-inch base can. With ultimately the fixture stays the same when we're talking inset fixtures, and then there's an adapter ring for the 8-inch. So you can do 5-inch or 8-inch. They're all shallow base is the standard implementation, but we can certainly do a deep base version if there's more space required inside the base can itself. Ultimately, it's available and it's usable, but it's based on the same concept. It's just a deeper can.
Yeah, thank you, Wade. And the final question, it's again from Anonymous, so I can't identify the requester, and it's a general commercial question, if you will. How does Avlite compare to other OEM manufacturers? I guess I'd respond by saying that we'd be delighted to get in contact with you and support you. It really starts with that sort of triage or that funnel of system in terms of your needs. So there's a number of ways to look at systems and solutions commercially, and if that person would like to reach out and contact us, we'd be delighted to support you with your commercial needs. Okay, I'd just like to conclude and say fantastic and thank you for all of your support and participation. We've had a wonderful turnout today. My many thanks to Wade, Vicky, and also our support team who make all of this possible. I'd like to invite each of you today to take part in a short 60-second survey at the conclusion. And until we meet again, please stay safe, and a big thank you for today's participation and your ongoing support of our business. Thank you.